Welcome to today's democast from the Construction Specifier and Kryton. My name is Farheen. I'm the Associate Editor for the Construction Specifier, and I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started, if you have any questions during today's democast, please enter them using the Q&A section, which you can find at the bottom of your Zoom window. We will address as many questions as possible at the end of the presentation. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, only use the Q&A instead. If you're experiencing any technical difficulties during the democast, you can enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's democast is being recorded and will be available on the Construction Specifier's website by this time next week. Now, I'd like to introduce our speakers, Craig Appelman and Jeff Bowman. Craig is a seasoned materials engineer with 15 years of experience specializing in civil engineering projects. He excels in designing, assessing, and repairing concrete, timber, masonry, and steel structures. He is actively engaged with Concrete BC, contributing to the Environment and Climate Change Committee. He champions sustainable construction materials, advocating for eco-friendly choices and addressing their challenges. Jeff is a key driver within the Kryton R&D team with more than a decade of dedicated experience in defining and developing best practices within the crystalline admixtures and repair materials category. Jeff has written extensively on waterproofing technologies and has helped to develop new products that ensure structural durability. In this democast, Craig and Jeff will discuss how sustainability, rising costs, and innovative cement solutions are shaping the construction landscape. They will discuss environmental considerations, key challenges, and practical changes in projects' cutting-edge materials, and government-industry collaboration and client inquiries, and evaluating environmental solutions. Craig and Jeff, we appreciate you joining us today. Please take it away.
All right, thank you very much. Thank you for having us. Craig, good to see you again.
Good to see you as well. Thanks, Jeff.
Yeah, so I think we've got a pretty interesting topic here, so let's just kind of jump right in. I'll set just a little bit of a background for everybody. And the reason that we're having this conversation and the reason people are joining us today is I think we can all see that the construction industry is really changing at a particularly rapid pace right now. And we've kind of identified three major factors that are driving a lot of that change. Certainly one of the biggest ones is just a ever-growing focus on sustainability of our construction material and our buildings related to the carbon emissions related with manufacturing, transporting, and using those materials. And another thing that's bringing in is a new wave of new materials that are being used. A big one being Portland limestone cement in concrete. That's been more common in some regions for several years, but it's newer in other regions, and everybody's starting to get used to the new way of doing things. And all of this is also happening against a backdrop of significantly rising material and labor costs that are putting a lot of pressure on the industry as a whole. And now it's my understanding, Craig, that the per unit carbon emissions of concrete aren't actually particularly high compared to some other construction materials that we might use, such as steel and plastic, but that the really big driver is that we just use so much concrete that it represents a significant portion of global emissions. Would you agree with that?
Oh yeah, absolutely. Yeah, that's what's that phrase or the fact where concrete is the second most used material behind water in the world, and so yeah, we use quite a bit of it.
Yeah. So, and it sounds like you're really kind of at the forefront of guiding people through dealing with these new challenges. So, just in your view, how are these new challenges around sustainability changing your approach to using concrete on your projects?
Well, I think what we need to do is we need to start considering how much environmental impact we're asking or we're creating by asking for, whether it be high performance concrete or, as we just mentioned, large volumes of concrete. And if we can make these small changes, and really what that means is reductions in cement, really in concrete, then we can see big impacts on on how much CO2 emissions that we're creating.
Yeah. So are you talking about just using leaner mixes or lower strength before than
Well,
maybe what people thought was necessary?
yeah, I think really it comes down to we just have to be a little bit careful in what we're asking for. If we need high performing mixes, then that's fine. Then we need to put the right amount of cement in there to achieve that. But on one hand, we got to make sure that that's what we really want, and on the other hand, if we need these higher performing mixes, try to do it in the most efficient way possible.
Okay. And when you're making some of these decisions, like who's really driving that push for lower carbon and more sustainable concrete? Like, is this coming from the design side? Is it government agencies? Is it owners? So what exactly are they asking you to do? And what do you think is motivating them?
Yeah, so I think there's a few different drivers right now, and probably the biggest one, at least in my opinion, it's industry. And by industry, I mean cement suppliers and ready mix suppliers. Um, and if I think the motivation for these guys is that they really understand the amount of emissions that are being created from their product, and they're trying their very best to maintain their viability in the current and future market. And so you see cement suppliers switching to things that you mentioned, like Portland limestone cement, and they're also exploring carbon capture and utilization initiatives. And really, they're just trying to reduce their emissions. And then you also see some government agencies really stepping up. And in one really good example of that is the city of Langford. Just recent, and that's on Vancouver Island in BC. And just recently, they published a new policy where it's called their low carbon concrete policy, where basically, if you're working on any project in that city for the city, then they're requiring that you meet some sort of upper limit for how much carbon emissions you can create to produce concrete.
Yeah. Now, my understanding is that you had some involvement in providing assistance to developing that policy. So what sort of help or guidance did they need to bring that policy together? Because concrete is a material that's largely not that well understood outside the industry.
Yeah, and I think that's exactly it. Concrete's complicated, and there's a huge range of different mixes, whether you're making footings or making the walls for a high rise. There's different ranges in compressive strength. There's different ranges in durability requirements, and each one of those levels or tiers of concrete, they have different environmental impacts. And so trying to create a policy to capture all those different types of concrete is a very difficult thing, and especially if you don't have any experience in the concrete industry. And so what we provided, what our assistance on that project was just providing some technical background and a little bit of clarity so they could create a policy that achieved their goals.
Yeah, I do find it quite interesting. Just going back to something you said about industry leading a lot of the change, it almost seems counterintuitive. I think people are used to governments coming in and mandating changes and industry follows, but I'd have to say I've seen that as well in our contacts with the cement industry and the ready mix industry. There's a lot of people they're really into it, trying to push these changes and manage them. And, I think we also see that I know that the two industries are under a lot of stress just for managing their materials and their people. I remember hearing there was a ready mix company who was back in January, they were almost booked for the year and were kind of telling their customers like, I don't know if we can take on many more projects. So, I also think they know that cement clinker is a valuable resource and they want to stretch that out and make the best use of it and get as much concrete out of it as you can. So I think it's really being identified as a valuable resource that needs to be managed.
Yeah, I agree.
Just to move on then. So kind of specifically, what sort of tools are you using to help lower the environmental impact of concrete on your projects? I mean, I think we're all kind of familiar with the use of slag and fly ash. They've been around for a while now, and they're used. GUL cement. Are those your main tools, or are there any others that you make use of?
Yeah, those are very helpful. Obviously, the CO2 emissions from, it's kind of a funny thing, but the CO2 emissions from fly ash are much lower than from cement, because fly ash is a byproduct of a different process. But one of the things that I lean pretty heavily on is the use of admixtures. With the new generation of admixtures which has come out, you can really, really drive down your water demand in your concrete. And what that means is, if you drive down your water demand, you can also drive down the cement requirement. And so you can get the same performance out of concrete using much less cement, and in turn, much less emissions.
Yeah, and I know it's not published yet, but there'll be a chapter in the new ACI report number 212 on admixtures that will be focusing on sustainability. That chapter's still in work, so I don't know exactly when it's going to be published, but it actually just kind of helps. It will help to highlight some of the other benefits you can get out of using admixtures, and certainly it references some of the huge reductions in water, that have been saved in the United States using water reducers, and it was massive. It's referencing like billions of gallons a year.
Wow.
I couldn't believe it.
Yeah.
But there's a lot of other ways that admixtures can help that might not be obvious right away to everybody. It can be simple things like I know people using viscosity modifiers can help to manage the slump and workability of leaner mixes or more challenging mixes. Even using accelerators in the winter, if you can shut off your winter heat sooner, it has a big difference on how much fuel you're burning. And if you look at a company like Kryton, the tools that we would bring, we would bring waterproofing admixtures, crystalline additives, and our other product, HardSem, for abrasion resistance. And they're really aimed at ensuring the durability of that concrete. I think, we really see that when you make anything out of concrete, it's very much an investment. Even if you're trying to minimize the upfront CO2 in that concrete, you really want it to last. Because if you have to, start to repair it or maintain it, not only are you consuming more resources to repair it, but there's a lot of downtime and a lot of really significant downstream consequences, to not having your concrete perform the way you'd like it to perform.
I agree. Yeah.
So I guess kind of to move on from that, though, what kind of challenges are you finding when you're trying to implement these solutions on a real project?
Yeah. The biggest challenge I find is that everything is changing very quickly. If you go back 30 years and try and look back at what concrete 30 years ago looked like, it looks nothing like it does today. And you have maybe different users in the construction field who aren't aware of these changes that are happening, whether that be ministries of transportation, or it be designers, structural engineers, or it be concrete finishers. And when these changes happen, for example, if you change from GU cement to GUL cement, or you're changing from fly ash to slag, or any one of these different things, or probably the biggest one is when you're using higher dosages of admixtures, the concrete changes. It's not the same thing. You have to relearn how to place it and finish it. And that's a huge issue for contractors, especially finishers. And we see a lot of improper placements that happen because of these. And then for the designers, for structural engineers, they need to become comfortable with it. When they see a mixed design submission that has a product that they've never heard of before, they need to make sure that they're okay with it. And the same thing goes for owners, and in particular ministries of transportation, for example. They need time to feel comfortable that whatever that product which is going to the concrete is going to provide them the durability and the service life that they require.
Yeah. So then how do you think we overcome some of those challenges in just getting people familiar with the materials and using them?
Yeah, I think it has to be education and it has to be collaboration. When we see new products coming on the market for concrete, uh, those need to be shared and those need to be trialed and those need to be, proven, and then that information shared around to all the different parties. And I think I actually do feel pretty bad for the concrete finishers and placers because no one ever tells them what's going on, right? The concrete shows
Yeah.
up on site and
Yeah.
they're just trying their best, and sometimes it doesn't go well, and they probably have no idea why. And so
Yeah.
I think that information just needs to make it around. That's all.
Yeah. I think one thing that, especially outside the industry and even within it, I think it's important to just remember that concrete is probably the only major construction material that we actually manufacture basically in place, right? It's not like your steel or timber that comes out of a factory. It can be quality checked and the rejects pulled out. So by the time it gets to site that it's ready to go. I mean, the way we work with concrete most of the time, it would be similar to if you molded a steel beam and poured the molten steel in on site and then waited to see what properties you get.
Yeah.
I mean, like nobody would ever build that way, but that's how we work with concrete. And so there's a human element, there are weather challenges, that the contractor just has to deal with. And I think I think that designers and engineers and even owners can do a great service to their contractors by just realizing that there are these challenges they have to work through. And the more time you can get them to really be prepared, even if it's just a trial mix and trying a new concrete, even if it's just a little bit different, even if it's only 5 or 10% different in setting time or bleed rates, all these little changes can pile up, and it can just make for a slightly different experience on site that the contractor's trying to manage. And they get really, really good at working with concrete they're familiar with, and a few little changes can compound and it can create difficulties for them. And if they're prepared for that, you can steer off a lot of those issues.
Yeah, I agree.
I guess that kind of brings us to, I think people also understand that concrete sustainability is heavily related to its durability and its longevity out of that item. So what can we do to, ensure the durability using these new low carbon mixes?
Yeah. I think that especially because of the new admixtures that are on the market, that at least in my experience, that it's pretty rare that we're seeing concrete which isn't performing. And what I mean by that is, it's kind of a rare thing to see concrete with 28-day compressive strength, which doesn't meet the specified strength. And if it doesn't, there's probably a reason why, and there's probably an error as to why that happened. What I see when I find durability concerns, at least on new structures, is that they're construction errors. And there were, cover wasn't checked on rebar, or if they didn't have a good consolidation plan for getting concrete into place, or if, at some point in the production, one person didn't really know what was going on and it led to some sort of error. And I think really what needs to happen in that process is everyone just needs to slow down a little bit and, reach out to other parties in the process, whether that be the designer or the ready mix supplier or the placers and finishers, and just make sure that everyone's on the same page. And use things like mock-ups and trial mixes, as you mentioned. Footings are a really, really good opportunity to do trial mixes for a building, because usually they're the lowest strength part of the building, so you can dump concrete in there just to see how it works. And if we can do that, then we can reduce the amount of errors we have, and we can reduce the amount of repairs that need to be made, and we can increase the durability of these structures.
Yeah, and that's an area where Kryton will try to push a lot as well, is that, sometimes you're not just using concrete, right? Concrete's an assembly of, different components. I'll give an example on, our waterproofing line. Waterproof concrete is not the same as a waterproof building, right? There's penetrations and construction joints and all these other elements that need to come together. And, we found that it can make a huge difference on the execution of that building if we have the opportunity to talk to the site superintendent or train their applicators, just to make sure they're really familiar with, if it's our water stop products being applied, exactly how they go down. And I'll say, look, I understand that, you might have people who have installed similar products, but there's a little bit different. I still think we can bring some value, even 5 or 10 minutes on site, just to show them exactly what these look like. It can really give them they can execute that job at a much higher level. We can work with the engineers, we can show them what it should look like, what it should not look like, how to troubleshoot those items. And these all make a big difference, right? Because if you're trying to make something watertight, the construction joints are where a lot of the problems can go wrong.
Yeah.
So it's kind of a bit of an Achilles heel. And
sorry, go ahead.
Yeah, just even on the admixtures as well, we also, find the trial mixes or the test pours and the footings are very useful, because if the contractor can just have that, that comfort level where they see it, they watch it set up, they check the temperature, they poke at it, they get some ideas of when it's going to be ready to finish. Now, when they're doing the main pour and they've got, maybe hundreds of cubic meters showing up, they know more what to expect. They're just a little more comfortable with it, and it can make a big difference. And the other thing too is, not that there were any benefits from COVID and all those disruptions, but it did help us get, much better at doing remote training, setting up in our laboratory and connecting with people over Zoom and doing demonstrations. So our ability to kind of reach out, all over the world and provide the sort of training and support actually increased. It's much higher than it was before. So, I think that is something that people can take advantage of for sure.
Yeah, that's great.
One other thing I would say to specifiers as well is I think curing is going to be more important than ever, right? Because I know the mixes perform well, all the tested NGUL cement looks pretty good, but quite often if it's not really enforced in the specification, sometimes proper wet curing or curing compounds as described by ACI just may not happen, because the concrete will still reach its strength. And you said that's not a problem, right? You can easily exceed your 28-day strength at 7 days. So why should I cure it, right? It's reaching its strength no matter what.
Yeah.
But when you're getting into the discussion of durability, we're really now concerned about that top inch or two of cover over the rebar. And that's at the interface with the air. That's where curing actually makes the biggest difference, is in getting the best quality in that vital barrier zone, where you're now protecting the steel from chlorides or groundwater or other chemicals in it. And so I think as you kind of optimize your mixes to use just as much cement powder as you need, or just as much strength as you need, I think ensuring that they're properly cured to really get the benefits out of that is going to be it's always been important, but it's going to be more important. So you're saying kind of slow down, and I'm thinking like also get back to basics, right? We all know these things are good for the concrete, and they're not going away. Even with all the new technology, the basics are still really important.
Or even more important, like as a good example, not even curing, but just initial protection of the concrete. 25 years ago or 30 years ago, when you just had straight GU cement mixes and a lot of water in there was a lot of water to keep your concrete the surface nice and wet, so it wouldn't dry out too quick.
Yeah, it's very forgiving.
Yeah, exactly. But now it's not forgiving. You've got to do, puts your cure and seals on, or you have to put up some shade or put up some wind blocks to stop that surface from drying out, or else you're going to get, a weak surface that'll potentially flake off on you.
So just finally then, what advice would you have for the industry? So what can designers do and what can government do to help ensure success in this area?
Yeah, so I think if you're a structural engineer and you're really concerned like I am, about global warming and environmental impacts due to construction, I think probably the biggest thing is know what you're asking for. As an example, there's been a couple projects where, if you're familiar with CSA, a designer they wanted 50 MPa because they wanted, so you put 50 MPa in a shear wall. And so they looked into the CSA 23.1 table and they looked for 50 MPa, and what did they find? It was CXL concrete. And there is a huge difference between CXL concrete and just normal 50 MPa. And there is a huge environmental investment to make CXL concrete. And so all I would say is become familiar with, the requirements for concrete. Make sure you know what you're asking for. I would avoid rounding up. Like if you need 30 MPa, don't round it up to 35 just because you feel like that will make you sleep easier at night. Like you just, be sure what you're asking for and try to optimize it as best you can.
Okay, so just before we move on to the Q&A, we were speaking earlier, and you had some interesting thoughts on the MOT, the Ministry of Transportation or Departments of Transportation, depending on your region, and the role that they can play in this. Could you just quickly summarize that for everybody?
Yeah, sure. I think that really MOT has an opportunity to be a really big leader when it comes to, spearheading in this new greener construction practices. And the reason why that is because so many municipalities and local governments, if they need to build a bridge, they're not developing their own set of specs, right? So they're looking to the ministries of transportation at their specs, and in most cases, they're just carbon copying it. And it's been kind of an observation, at least of mine, that some MOTs are a little bit stuck in their way. It worked 40 years ago. By golly, it's going to work today, and that's not really the case. Everything's changed, and we can't really afford to not adopt new materials in a timely manner. We need to move quickly, and I think that like I said, there's an opportunity for the ministries to be the leaders, to look to new materials, to try to adopt them as quick as possible, because they have a huge trickle-down effect to everyone else in the industry.
Okay, thank you. Why don't we wrap up our conversation there, and we can start to open it back up to our host for the Q&A.
Thank you so much, Craig and Jeff, for this excellent presentation. We do have some time for questions now, so just open the Q&A located at the bottom of your Zoom window and post your questions. We already have a few coming in, so let's get started with these. The first question is, what about carbon mineralization technology, and does it make concrete low carbon?
I can answer this one. So what carbon mineralization is during the batching operation, you can inject dry ice or solid carbon dioxide into the back of plastic concrete, and that carbon dioxide will react with some of the cementing materials that are in the back of the truck to form calcium carbonate. And what that does is it actually increases the potential compressive strength that you're going to get in that concrete. And because you have a slight uptick in your compressive strength, you can potentially reduce your cement content. However, it is not the solution. It's a tool that you can use to reduce, I should say, your carbon footprint of your concrete. Just using carbon mineralization does not mean you're making quote unquote green concrete, but it is a tool that you can use to work towards that.
Thank you. How can low carbon concrete be specified? Are there any resources to help with that?
Yeah, so I think that if you're using performance-based specifications, then it is relatively easy to include performance-based CO2 limits. So It is pretty common now that ready-mix suppliers will develop what are called EPDs, which stands for Environmental Product Declarations, for each one of their concrete mix designs. And as a designer, if you're unfamiliar with what a carbon content of a particular mix is, I would suggest that you reach out to organizations such as Concrete BC, who have really good resources on what typical environmental product declaration values are for different types of concrete.
I would imagine that different regions too, each local organization will have their own resources to help specify it in their area. So I think that ties into Craig's comments that the industry is providing a lot of leadership in this area.
Right.
Thank you. Is CO2 reuptake more rapid when low-grade structures aren't covered by a membrane?
Do you want me to answer this one, or do you?
Sure. Maybe they're looking at carbonation.
I think they are, and carbonation is a funny phenomenon, and it typically doesn't happen very quickly in exterior concrete. Normally, carbonation happens at the fastest locations it happens is at about 23 degrees Celsius and 50% relative humidity, which, if you think about it, it's interior spaces. So interior concrete, like inside office buildings or inside of homes or whatever that are conditioned spaces, that concrete is actually carbonating the fastest. So in exterior applications, it's the carbonation rate is very slow.
Yeah, and I would think slower too underground if you're backfilled with soil or damp soil.
Yeah, exactly. Yeah, there has to be carbon dioxide there for it to carbonate.
Thank you so much. And the last question I can take here is, how does the embodied carbon of a high-grade waterproofing membrane compare to a crystalline admixture?
Yeah, well, I don't know that, every membrane is going to be different, is going to have its own composition. Crystalline admixtures are not all the same, so you wouldn't necessarily, treat them all. I think you'd have to look at each case individually. But there's still room, though, to look at what systems make, the most sense for your project. To give an example, one area where our waterproofing admixtures might be used would be in cases where the detailing of a membrane work around soil tiebacks and other penetrations is just so difficult for the membrane, that it places a lot of stress on the contractor to try to execute that. And so in that case, the simpler solution that's easier to install with fewer mistakes gives you the best result. And the carbon footprint of those waterproofing materials are still going to pale compared to the concrete itself. So we're really trying to get the best result for the concrete. That's how I would look at it.
Thank you so much. Can we switch to the slide with your contact information on it?
There we go.
Thank you. Thank you so much, Jeff, and thank you so much, Craig. And thank you to everybody who joined us today. That was all the time we had for questions. If you need to reach out with any additional questions, the presenter's contact information is currently up on the screen. Just a reminder before everyone leaves, if you would like to rewatch today's presentation or share it with a colleague, we'll be emailing the link to the recording to everyone who registered for the democast within a week. So keep an eye out on your inbox. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey as it helps us to continue to serve your needs in the future. On behalf of the construction specifier and Kryton, thank you so much for joining us and enjoy the rest of your day.